Alright guys, welcome back. We have a 3-span beam here that's second degree static indeterminate, and we want to use the 3-moment equation to draw the shear force diagram, bending moment diagram, and solve for the reactions. This is going to be a 3-part video, so this is part 1. And the first thing that we want to do is we want to draw the bending moment diagrams for each of the spans as if they were simply supported and carrying the same loads. And then we're going to need to find the x bars for the 3-moment equation. So if we call this span 1, span 2, and span 3, then we're going to need, what we're going to do, and also let's label these reactions. Let's say we have A, B, C, and D. What we're going to do is we're going to apply the 3-moment equation over span A, B, C, and these are going to be the 2 spans that we're working with, 1 and 2. And then we're going to apply the 3-moment equation again over span B, C, D, where we're dealing with equations, spans 2 and 3. So the first time that we apply the 3-moment equation, then x bar 1 is just going to be equal to 5 meters. And we're going to need to find the location for region 2 here, x bar 2, from the right-hand side. Then when we do the 3-moment equation for the second time on span BCD, we're going to need to find x bar 2 again, but so this time it'll be from the left-hand side because we're always coming from the outsides of the 2 spans that we're looking at. So this will be x bar 2. And really what we should do is we should add on a subscript here. So this is going to be x bar 2 for A, B, C, and this is going to be x bar 2 for the iteration that we do that is B, C, D. And in that second iteration, then we're going to also need x bar 3, which is 5 meters. Alright, so to find x bar 2 BCD or x bar 2 ABC, we basically need to take the centroid of composite shapes. So if we do our formula starting here going to the right, we're going to find that x bar 2 BCD is equal to 4.333 and x bar 2 ABC is equal to 5.667. And if you're unfamiliar with how to do this method, I'll put a link to a video that I made in the description if you're looking on YouTube. Or up here, I'll make a little bubble thing, and that'll take you off to that video as well on how to find the centroids of simple composite shapes. Now, there's also usually another way to get these centroids or the distances of these x bar values, and you can do it by table. So if your textbook has like a 3-moment equation table, you're able to use that. But if you're in a test with a closed book or something, and you end up finding something like this that's not symmetrical, then you're going to have to do it by composite shapes. So it's just a good thing to know to be able to find those centroids of composite shapes like this. Alright, so we're just about ready to do our first 3-moment equation on span ABC, but before we do that, let's just recognize that we do know that MA is going to be 0 because it's on the free end, or like basically the end of a span there. MD is also going to be 0, but we have MB. This is going to be an unknown for us. MC, this is also going to be an unknown for us. This is the internal moments at B and C. And then the internal moment at MD, like we just said, is also, we know that's going to be 0. If you drew a virtual cut infinitesimally close to that, you're going to find out that that is 0. So basically, this is why we do the 3-moment equation twice, because we have 2 unknowns and we need 2 equations. So this is the 3-moment equation for a span ABC, and because the problem up here specified that EI is constant, you'll notice that EI is in every single denominator, so that cancels out and we're left with a slightly simplified version. So we can go and fill in some of these values now. We know that each of the spans was 10 meters in total, and we did calculate these values for A1 and A2, and then x bar 1 and then x bar 2 for ABC. So this is the one that we're going to be using in this expression. So if we just plug and chug a little bit, we'll get the expression 4MB plus MC is equal to negative 366. Alright, now what we want to do is we want to redo the 3-moment equation over span BCD. So if we just go up to look and see what A2, A3, and then the x bars are, when we're going over the span of BCD, then we're going to be needing to use this x bar 2 BCD because it's coming from the outside, so that's 4.333. And then this x bar 3 is 5 meters, area 2 is 525, and area 3 is 833. The other thing that we did notice is that MD is equal to 0, and that's going to be used in this expression. So we can plug in those values, and then we can just simplify this to find out that MB plus 4MC is equal to negative 386.5. And really what we have now is we have 2 equations and 2 unknowns. So we can either solve that by simple substitution or using a 2x2 augmented matrix to get the internal moments at B and C. So I'm going to pause this video here. That's going to be the end of part 1, and join me in part 2 where we're going to solve this matrix and then figure out what all the internal moments and shears are basically at the ends of each of those spans. And then in part 3, come back and we will draw the shear force diagram, bending moment diagram, and solve for the reactions.